Yeah, so welcome again. We're at double digits, community call 10. Let's go. I know we have some new people here, especially from those who hacked with us at ETH Dam. So I'll just explain a bit about what these calls entail. Oh, it's not February. uh, so yeah, these calls are just a time for the community to come together and discuss what's happening with zero knowledge in the ecosystem. And we try and keep it free format, so more discussion back and forth. But we have a lot of people presenting, and people like to see what others are up to. So yeah, everyone's welcome to participate. Just speak up, raise your hand, type in the chat, whatever you're comfortable with, and you're encouraged to participate as well. We love like a lot of discourse and stuff. So yeah, myself, I'll just moderate this call. I don't make any decisions about proposals or whatever in this call. That happens asynchronously normally by the work group and other entities. And yeah, I'm recording this call as well, and it'll be uploaded to YouTube afterwards. So here are the topics that have been suggested for today, except the top one. The top one is by myself. So I'm going to talk a bit about the infrastructure committee, and then I think we have Zero Pool here as well to talk about their near privacy standard token. Then we'll have a presentation from Octopus Layer, who built a project at ETH Dam. We have Risk Zero joining us here, and they're going to talk about some stuff. Should be interesting. And then Jose, my friend Jose, will be talking a bit about whistleblowing and how ZK could be used for that. So I'll just speak about the infrastructure committee a little bit here. I should be able to, I don't really need to share my screen, but I can share the link. So there's this new basically funding node that has been put up in collaboration with the NEAR Foundation, which is, they have a budget of 4 million to fund, well, infrastructure within NEAR. So whether that be like RPCs or wallets or zero knowledge infrastructure. So they don't have any specific calls for proposals with ZK, but now if you're looking to get a grant for building ZK infrastructure, then the best place to go is this infrastructure committee. And I'll share this link in the chat as well. But this is just a link to a blog which will explain it in much more detail than I can go into here. But if you have any questions about it, just let me know and I should be able to help out. So should we pass it over to Zero Pool to dive in?
Okay, so let's discuss Zero Pool near privacy token standard. What have we done? We implemented an extension for fungible token standard. It's available in our GitHub in repository Zero Pool near in Zero Pool network. So how it's working? We add additional functionality to token, providing deposits and withdrawals and in-pool transactions for privacy pool, and attach privacy pool related verifier and logic to the token contract. So it is fungible token contract, but with additional functionality. So inside the pool, user experience is the same as with our existing privacy pools. It's deposits, withdrawals, and transactions. So that's it. Also, we support two proving systems. It's Gross16 and Plonk. So if somebody who wants to use token standard is going to make trusted setup ceremony, then Gross16 could be used. For case with no trusted setups, Long is useful as also.
So in a few words, from our side, research and development is done, and as I wrote in our Telegram group, now we are looking for someone who can take organizational part, who can take the part of interaction with users, and maybe customizing front end. Of course, we are ready to support this, but we are ready to support the engine of this solution, but we don't have any opportunity to support the whole privacy token standard and to deliver it from the very beginning to the end, because we think this story should be decentralized as everything is in the near. Because it's not good when in decentralized community, in decentralized infrastructure, something totally dependent on one team. And we against of it, and we can take responsibility on research, on further development of this engine, of course, of support, but we need someone else for this solution.
For example, we have we are working with ZK-Bob. We provide them our solution, including front-end side client, relayers, smart contracts, and so on.
But to say about front-end, we help them with front-end, but all design and user experience are from their side, not from our side.
Yeah.
From our side is only technical support of this solution.
Yeah, I mean, WASM provers and such things.
And this solution is almost 2 years in prod. There is no issue with it, and we support this engine, and we can customize something for them as we did it, because they requested something, we customize it. But it's a decentralized solution. They are responsible for user experience, for legal part, for something else, and we are responsible for engine. The same we are looking for here.
If someone was looking to get involved, what would the best way to contact you be?
What do you mean the best way of contacting us? So we are in Telegram, so we are open. You can write me or Igor. We are both in Zero Knowledge near group. After this call, I can repeat this message once again, so it will be more easier to find out us.
Yeah, for sure. I think that'd be great.
Okay.
Awesome, thanks. Does anyone have any questions about that? I was wondering myself whether is this going? Are you going to like open a NEP about this? Like how there's a near standard for tokens. Are you going to open like an official NEP for like the privacy token? If you understand.
Yes, it could be described as NEP, of course. It's not an issue. We can provide this documentation. For now, we have just implementation. We have documentation of the pool on our website. We can provide it as extension for token as Snap standard. Yes.
Nice. Any follow-up? Anyone? Or shall we move on?
I've got one quick question. You're mentioning that you're supporting Groth 16 curves. Is it over any specific curve? I would assume it's over 254 with like the precompiles from Near, or is it something else?
We implemented support of these curves on Near, so it's at ban 128. So it's standard curves.
Gotcha.
And for Plonk also standard curves. I know there could be some issues for making Mina protocol on Near because the curves are different. For our case, we support Near snarks. We implement these precompiles.
Okay, I think that seems like it's it. Is there anything you want to add more to that? Yeah, I think it'd be a great idea to put to reiterate this in the chat after the call.
Yeah, sure.
Okay, thank you. So we'll move to Octopus layer next if you want to present, and I'll give a little bit of context. So Octopus layer were at ETH-DAM, where we were sponsoring as well, and we had 12 submissions there, which was amazing. I think that's the most we've ever had, and these were all like proper valid submissions. And Pedro was also there, who helped out a bit. So thank you for that. So yeah, please go ahead and share about Octopus layer.
Yes, of course. Thank you very much, first of all, everyone. Can I share my screen?
You should be able to. I'll take
Okay.
mine down now.
Yeah. You can see, I guess, right? Can you?
Looks good on my end.
Okay, great. So yeah, this was a hackathon project. Start like hackathon project, but we really like the idea, and we really feel that there can be something beneath this idea. Basically, we tried to create chain agnostic snark-proof verifier layer on top of Near. There was different reasons why we chose Near. I will explain further. First of all, what's the background? What's the problem? First of all, we need ZK snark proofs. That's the only way of providing on-chain privacy. So having an easy way of integrating proving ZK snark proofs on Near without that can be very useful for Near developers. But even though ZK snarks are verified in constant time, still it's costly to be implemented. It's hard. Cryptographic schemes are not that easy. And O1 time complexity is the theoretical limit, but it's not as easy to achieve that. So we thought that it's not really easy to do that in Near. Like for hackathon, it was impossible, but in general too. Plus, in terms of proof aggregation, ZK snark proofs are much stronger when they're aggregated, but not all ZK frameworks are strong in the proof aggregation side. But some specific technologies are better. I will explain further in a bit. And finally, it's not really developer friendly to use very different programming techniques to generate knowledge proofs. So without that, why don't we enable the power of JavaScript, TypeScript with Near smart contracts to actually allow everyone to implement their ZK proofs very easily? And that's why we used O1.js, the ZK framework language in Mina. Maybe you are familiar. In client side to create full privacy and create ZK snark proofs, and then using our Octopus layer, basically distribute these proofs into Near. And finally, using Near's multi-chain model, actually make these public outputs of ZK Snark proofs available to all chains. Let me give some background and I will show the architecture then. First of all, there's Near, I guess we all know. But like, first of all, I think the very important point here is that Near has a strong consensus, is a strong settlement layer, but storing huge amounts of data in Near, not expensive, but it's costly, it's in a data chain. So I think that using ZK proofs and using an external layer for proof verification is more efficient, even though I'm not an expert in Near's architecture. Then there's multi-chain, which is very exciting, but it allows us to actually, only use Near to settle, but then be able to broadcast our public outputs of our proofs to anywhere. And finally, there is this data availability. I'm not sure if it's fully ready on Near, but they are talking about light clients. So if Near light clients are there, our layer is also ready to be integrated into those light clients, so that like it creates proof availability, I would say, for Snark proof verification. Why O1.js? First of all, it's zero knowledge, so it's easy to use in any front end. It's really easy, to start using. You can check it out. But the main reason is that there's something called Pickles API inside O1.js, which is specifically used on top of Blanc proofs to have proof aggregation. And that's like the biggest strength of O1.js. Sorry, is there a question or anything?
Oh, I just typed in the chat.
Okay, sorry, yeah,
Use
there was a dent that I
on
missed.
DA.
Yeah, thank you. And yeah, finally, they can export that JSON files natively. So I guess that's also an advantage to be broadcasted, I guess, more easily on a layer like ours. So yeah, this is our architecture. Basically, we create our knowledge proofs in the client side with O1.js. We don't do any proof aggregation as our own, but you can use the client side to aggregate your own proofs. You can send as many proofs as you like at once to the verification layer. There is no limit. I guess, as I said, that's the biggest strength of O1.js. Proof aggregation is quite complex and quite fast. So you can create very custom structures using O1.js Pickles API. And then you get these proofs. And right now you have a proof, a ZK Snark proof, and you want your ZK Snark proof to be on the Near. On Near side, we have two contracts. One of them is the verifier contract that's specific to the Octopus layer. There's only one verifier contract. It's like a constant contract, I would say. And it is used for communication between the nodes of the Octopus layer, but also communication of this client side and the Octopus node. That's the first part why we use Near light clients. It's also used to verify that this layer always stays trustless, but it doesn't do the application part. When you will use the Octopus layer and you will do some custom ZK Snark verification, you would, of course, want to assert your proof to some on-chain state. You can do it by creating an application contract. It's a regular Near contract. For the proof of concept, we defined our own rules, like you should have a public output, a public assert statement, and a public output state in Near, so that like the proof can set public output and can read through the assert state, etc. Like there are small limits, but basically you can deploy anything as an application contract on the Near side. Once your ZK proof is ready, you don't directly interact with the application contract. You actually don't send the proof to the Near directly. You send the proof to the Octopus layer. First, you connect to the verifier contract, either through an RPC or through your own light client, and you get the list of nodes, Octopus nodes, I mean, from Near. Octopus nodes are very light, small proof verifier nodes. Anyone can join the layer. They are just responsible for verifying the proofs that they get. And they don't have data, they don't have consensus. Once you get the full list of nodes, either to one or to all of them, you send the JSON proof and you say, can you please verify and settle this on-chain? You can incentivize the application contract before sending your proof, or application contract can be incentivized by the application owner. That part is not specified in here as it was a hackathon project. I guess incentivization is easy. There's only one very specific point that makes this layer fully trustless and available. I will explain in a bit. Once the proof is on layer, the nodes first verify the proof. While verifying, get the on-chain verification key. The verification key is specific to every application, of course, so they make sure that they are verifying the right proof. They also get any on-chain assert state, so that like you can assert your proof to some on-chain application contract state. And they also, that's all, to verify the proof. Then once the proof is verified, they get the URLs of other nodes, again from Near. So they don't actually store the URLs of other nodes. They don't know where other nodes are. They reach other nodes through verified contract as well. They get the nodes and they just create a gossip. They say, okay, that's the proof I have. That's my signature. I signed the proof, and you can sign too. They sign, of course, with a Near private key, and then they create a gossip. Once they reach 66%, they settle that proof's public output on Near with 66% of signatures. During settlement, we verify all signatures are okay through verified contract, and it's all good to go. Here, the layer is trustless, because anyone can join the layer through 66% incentives. But it's not. It does not require a consensus, because once the settlement is complete, not the settler node is incentivized, but all signatures who were in the settlement transaction are incentivized equally. You don't receive a money because you settle. Rather, there will be a right to deposit, like something like that, on the Near contract. So once you settle, all signatures in the settlement are shown to have some kind of deposit, so they can get the deposit and they can be incentivized. And since the incentives are equal for all the nodes, they don't compete. There is this perfect game theory, and they just try to sign as many proofs as fast as they can and settle in Near as fast as they can. And once the public output is on Near, you can just use multi-chain to submit the result of the public output to basically anywhere. Here, the ZK Snack proof verification is done completely off-chain. So we make use of the power of Web2. These nodes can be as fast as you like. They can be light nodes because they don't have state, they don't have data, but they can also be very strong, like Rust or Camel machines, to enable the fastest proof generation possible. But yeah, so in that, that's the point. Like, we do the proof verification outside. That's why it's fast, it's trustless. Of course, the tokenomics of the model should be worked a bit more. So yeah, to give some final details and next steps. So yeah, first of all, they are very light, so you can even deploy them in a browser. That would be an interesting improvement. In some future iterations of the product, we actually are considering of getting rid of like this layer entirely and using the client side as a whole to make responsible of the proof verification. So clients would be responsible for generating and verifying zero-knowledge proofs at the same time, since they can join and leave the network very fast. So there's no data, there's no synchronization. So that's why once you connect to the application, the node can be started in your browser instantly. So they are rewarded equally, as I said, so they don't compete, they work together. There are no consensus because they all try to achieve the same thing. And yeah, I guess that's the main points of the current architecture. This does not allow proof aggregation on chain, I would say. Of course, you can use O1chess in client side to aggregate as much proofs as you like. But in that, the idea of this layer is about proof verification. But we are considering of improving this architecture, of course. It was a hackathon project, so our initial approach was only to being able to verify ZK Snack proofs on top of Near. So first of all, yeah, incentivization is missing. We are right now keeping a public key list on Near, which is not optimal at all. If you have a Merkle root in the verifier contract, that's like much less data, much more optimized. So that should definitely be implemented. The joining of a new node should be modeled much better. We can set incentives to make sure that the set is always at some constant size. Like if there is less than 100 nodes, then incentives are so high that people are just dying to get in. And once the number of people in the set passes like 120, incentives are so low, like no one else is joining, so that like we always have some kind of static size. Or else we can create incentives so that as there are more and more people joining, there are more and more incentives, so it doesn't affect the system at all, and we have as many layer nodes as required always. That can be achieved through like browser verification, maybe. Of course, there should be an npm package wrapping all this functionality so that like this is much easier to access. Not explained here, but I guess the most exciting part of this project is actually being able to use this layer for proof aggregation as well. If you have some light modular nodes, there is no reason for you to not use this layer to also aggregate zk-SNARK proofs. The only problem is that when the ordering of proofs is important, like for financial applications, since it can create a risk of arbitrage, there should be a layer responsible for ordering these proofs. Because if all of these nodes act like a sequencer, then you need a consensus protocol so that like these nodes can agree on the ordering of zk-SNARK proofs on the settled transaction, which is not ideal because we want this set to be as light as possible. A possible way of achieving this without changing this architecture too much is using a DA layer integrated into the system. Of course, Near, if it's truly achieves to be a DA, can be used. But a DA with more data-specific needs can also be used without any computation environment. I think that in that sense, Near makes more sense for consensus and settlement than the data storage. If there's a DA layer, the DA consensus itself can be used to order these transactions. The clients send their transactions to the DA layer. The nodes get the transactions from the DA layer, sign it, verify it, and set it on Near without changing the order. That can be an interesting way of achieving trustless ZK rollup execution. I guess that was all. Sorry, it was a bit long. Thank you, everyone, and if there's any questions, love to answer. Yeah, thank you. Any questions or anything?
I think we had a hand raised before. Did someone have a question?
Yeah, Social Cap. Hello, Leonardo.
Hey, how you feeling?
Yeah, we actually meet before, so.
I wonder, well, as obviously there whilst you were building it, but what did you find most difficult to complete as part of the hackathon project?
Oh yeah. First of all, it wasn't complete as a hackathon project. Like if you see the code, it's halfway done. The multi-chain wasn't working great because there was only an example for the coin exchanges, and we find it quite hard to actually use the same structure for custom state transitions. I thought it should be easy, but somehow we weren't able to do. Plus, like this would create much more value is other chains if other chains were also implemented. Right now, I guess there's only possible in Ethereum and Bitcoin. So for our case, it's only for Ethereum. It would be much more interesting if there was Cosmos 2, etc.
Yeah, there are more chains available, not with like Gas Relayer. That's just for Ethereum, Bitcoin, and Binance Smart Chain. But any I don't know how is it EDSCA or ECDSA?
Yeah,
I can never remember the order. But any chain that follows that curve, you should be able to integrate with. It just might be more difficult to do so than the given examples. Like Solana, you can't do that right now, but that's apparently coming. So watch out.
Yeah, thank you.
Does anyone have any more questions about that? It's really interesting to me. Not that I understand it really.
Why not do everything inside Near and having the layer if it's actually cheap to verify, and you can have like multiple smart contracts verifying it on site in Near? Why the layer? Doesn't that bring like an extra? Yeah, you go ahead.
Yeah, sorry. I guess it's about the next step. So for now, I guess it's hard to implement that kind of Plunk verifier or OneJS verifier on top of Near. That would take some time. But even if when you do, that's not 100% decentralized because it's not modular. You depend on Near for everything. And at some point, like, this is not the optimal solution. And in the long run, if we can actually use this layer as only part of the browsers without any external nodes, then we would enable, proof verification in a truly decentralized, distributed sense, I would say, because every participant joining the network would actually making the proof verification process faster and stronger and with less trust. I guess that's like the next step of Internet 2.
I see. Nice. Would you share your GitHub? You
Yes.
might have had already, but
I should have, sorry.
thanks, man.
You.
Awesome. So I think it seems like everyone is content. Thank you for that presentation. Really interesting. I think that's maybe the second or third time I've seen it now. So I know we have the like Austin here to talk about what were you going to talk about? Something with RISC-0 and maybe related to Near. So yeah, if you have anything to share, that'd be really interesting to hear.
Yeah, absolutely. So yeah, just to give some context, this is somewhat of a last minute addition to this call. So I don't have the like presentation of slides and everything, and I'm hoping to just like chat through some ideas, and I have at least a PR that I can share with people just if they're curious about some code. And if anyone has any questions as we're going along, feel free to just unmute or send something in the chat. The two things I had mentioned I was going to chat about, the first one being outcome proof verification in a zero knowledge proof, and the second one being basically a RISC-0 verifier on Near. And these are both kind of like very experimental. Like I do want to prefix that with like, yes, these things did not really even exist like 24 hours ago, very much early stages. But hopefully just get a discussion, see what people are looking for, see what would solve people's actual use cases. So I shared a PR for the first part of this, and there is some context. Yeah, but it was somewhat forced. But I mean, it was a great reason for me to like force myself to like do these initiatives because it's been on my to-do list for a bit. So yeah, so the first part is transaction outcome proof verification in RISC-0. So this is somewhat a buildup of what was talked about, I think on the last call. It might have been the last one or previous one before that, where my friend Hans gave like an explanation of the actual like client proof in RISC-0. So the context, all you need to know about here is the light client is basically a way for someone to verify the consensus of the Near blockchain. So you can say, a certain range of blocks is actually valid, and it's basically just doing some validating the like validator rotation, like signatures, and a bunch of other validation of the blocks. And it's also a recursive light client block verification. So you can have basically one proof, which could either be a snark or a SARK, and it'll verify any arbitrarily long amount of Near light client blocks. So that was what was chatted about before. And the part that is the addition on here, which is the PR I linked in the chat, is something that was somewhat hacked together over the past day. And essentially it's the other part or the extension to the light client protocol, which is essentially you sent a transaction and you want to prove that transaction is actually included and is based on and is connected to the actual like light client block that you've verified. This is useful for a lot of different things, like say interop, like Rainbow Bridge, for example, is going to do the light client block verification, but then for each user action, basically each user transaction, it's also going to do the outcome transaction proof validation. And how this is set up in the PR is essentially the outcome proof is composed with the block validation. This is not necessarily something you might want to do in an actual like production scenario. Like you might want to have it structured a different way. Like for example, like most, a common pattern is to have like a single block, like basically the light client block validation being done by one party, and then each user would just basically reference that block hash and do some proof on top of it. But it's kind of like an interesting use case and then easy to kind of remove later if you just want to do the transaction outcome proof. Right now, so basically what you're proving in one of these proofs is I have a transaction that is valid from a specific block height, and that's kind of like a lot of statements all in one, and then that can also be composed with other logic. So say if you want to prove some other statements, or you want to create some assertion about what exists on near, or any other arbitrary logic, you can easily compose that and do everything all within one Snark or Snark. So does that high-level explanation make sense to everyone? Does anyone have questions about that before I kind of move on to some other parts? I'm seeing some thumbs up, so it seems like that generally makes sense. So yeah, let me just yeah, that one's pretty much ready to go. Like it's working in a general sense. There's some like slight gotchas here and there. There was a somewhat of an issue I was running into with the proof RPC that is somewhat resolved, but yeah, I still have an open discussion on Zulip about that. And yeah, so I'll chat about just the other part, which is the near verifier. This was something that there used to be, I think about a year ago, there was a Stark verifier on near for basically there was an example that RISC-0 had. And since then, a lot of things have changed. And also, like just the ability to basically verify Starks and Snarks would be useful just to kind of compare how they actually run on near. This kind of dovetails very, into what was previously chatted about, like very similar to the, I guess, Mina case, except this one, the intention is to just verify right on near. That's also built, but the surprising thing is that the Stark and Snark verification through like software, just WASM verification, is actually above the gas limit, which was quite surprising. So I need to debug that. Maybe there's something with the sandbox testing node that, something is strange config there. It was literally just done in an hour, so I do need to go back into that and see what the issue is. But yeah, basically the use case here is, say you're an application developer, you want to create some statement of truth about some computation, or you want to create some sort of zero knowledge proof. The benefit for using RISC-0 in this context, especially on near, is that you're already writing your contract in Rust, and being able to like write a zero knowledge proof in Rust, and basically, if anyone's not familiar with RISC-0, it's basically a RISC-V virtual machine. So you're basically writing Rust code. It compiles down to somewhat of a variant of RISC-V bytecode, and then that just gets run through the ZKVM and will create a proof. So basically, the benefit here is that you can write your app completely in Rust, and you could add some like either private, if you have some like privacy use case, like it kind of hooks into like what Zeropool was talking about before, and potentially there's an overlap there. Or just like if you want to do some arbitrarily large amount of computation off chain, you can kind of keep all of your logic in Rust and use RISC-0. And then, as I mentioned before, the target is either a Stark proof or just a regular like BN256 Groth16 proof as a snark. So yeah, I should soon have a place to link for that code. It's very much just I just have the code locally. I mean, if it's useful for anyone, I can share my screen and share what that would look like. But I mean, there's really not too much to show. I'll just stop there if anyone has any questions around like that type of flow or how it compares with what was chatted about earlier on the call, because it might be helpful to kind of explain some of the differences.
So you're saying you could not verify on Near because you're exceeding the gas amount?
Yeah, there's some cryptic errors. The error was actually something along the lines of the contract not having enough gas to pay for storage, but there was actually not anything being saved to storage. So it might be something to do with this sandbox testing. I'm not quite sure. I haven't had the time to test it on. I'm right now looking into testing it on testnet right now. But it's likely surmountable. But I mean, eventually the end game would be to use like precompiles and just doing like Groth16 using that, just because it'll be cheaper. Why not? Yeah, I can't see why it would be over any sort of gas limit, but that was what was being run into. So yeah, I'll look into that, but it shouldn't be. That should definitely be surmountable.
Yeah, we were verifying on chain, and we have some tests. Maybe it will help. I sent the repo in the chat. It's been a while since I haven't gone through the repo, so that's the best I can do to help.
Yeah, I appreciate that. And what kind of proofs were you verifying on chain?
We did both for Groth16 and Plonk.
Cool. Yeah, I'll look into that. And I think as ZeroPol was mentioning, they have the Groth16 verifier as well.
Yeah.
So yeah, either one of those. But yeah, that would. And I take it you're using the precompiles through Near, or were you just doing like a software verification?
Ooh, that's a good question because I did not write it.
Okay, gotcha. Yeah. Cool. But yeah, that's that was definitely helpful. I'll look into that after. Appreciate that. Does anyone else have any like other thoughts? Like, I mean, if anyone has like not even just a question, but just like kind of an anecdote or something that they want to chat about before, because that's pretty much, I just wanted to share all that at kind of a high level. There's not really anything else that I wanted to cover today. So yeah, if anyone else has thoughts, I'd be happy to chat about this. Or if you have any sort of use case that would be useful for this, I'd love to hear it, because then, maybe there's a collaboration there.
Yeah, I wish I understood enough to ask questions. Hopefully in a few months' time.
Yeah, I mean, even if it's like a dumb question, I'm happy to try to draw some lines. I mean, it's possible I didn't make that as beginner friendly as I could have. So I'd love to hear if anything was like super confusing.
Yeah, nothing for me. From me, I think people might have questions afterwards. So I think Austin would be up for like if you want to message him or whatever about it. Okay, thanks a lot for that, and I appreciate you putting something together so quick. That's awesome. So Jose,
Yeah, thanks,
would you like to share about this whistleblowing thing and possible use case for ZK? We sort of had this as one of our potential use cases for the hackathon for ETHDAM, because we always like to give some people ideas if they don't know quite what they want to hack up yet.
Sure thing, Owen. Thank you for having me. Hello, everybody. Let me share my screen. Can you see it? Slowly. Okay. The idea is this is a real use case for zero knowledge, and use it as a cornerstone for build the ultimate whistleblowing tool for the European countries. The idea here is that this come from a directive of the European Union. You can Google that to have a guideline. It's the 2019-1937 European Parliament directive. This is a mandate for all the European Union countries to create laws to protect whistleblowers in the European Union, and how to use compliance as a path to mass adoption of blockchain technology, right? And this is important because when you use compliance as the use case, the need is out there. It's not about proving that the potential users or consumers that you get an opportunity, or you need to point out that there is a need that you can cover with your product. In this case, the need is out there already. This directive came from in 2019, and most of the European countries rule on this issue on 2022, so it's quite new. This directive mandate to all companies and public entities with more than 50 employees to have a whistleblower tool or service hired. It's a possibility for someone who works in the city hall or for the government or in a big company. They should have the opportunity to make a complaint, about an issue that they notice that when the company is breaking some laws, some European laws, the employee should have the access to present the case without compromising their identity, right? So the number of potential users for these products is 71 million of people. This is the number of people that works in a company, only in the private sector, in a company with more than 50 employees. So you need to add to the number the number of people that works in the public sector, right? And potential clients, if you make the numbers in the European Union, is around 341,000 companies with more than 50 employees. And again, this is only in the private sector. And the idea is to create a product, or the potential cases to create a product that really cover the security required for a whistleblower tool. And you know what? But let's see what is the problem. Right now, if you make a Google search on whistleblower services tool in European Union, wherever, you will find several companies. And what the companies do is that they delegate the security of the data on a third party. They hire a company that provide these, whistleblower services or whatever, but all these companies are custodial. So there is always a chance that these whistleblowers' identities could be compromised through, wrongdoing of the custodial company, or for, they suffer a hack attack or whatever. So so far, all the solutions out there are not that safe. So delegating the liability is what the companies does. It's like, I don't want to, I want to comply with this law, but I don't want to, build all the stuff and secure the data, everything. So they delegate the liability. If they hire a company and that company suffer a breach of the information or whatever, the responsibility is in that company. But that doesn't really protect the whistleblowers, right? So the current solutions raise concerns about the data security and the proper compliance for the whistleblowers. And guess what? Zero knowledge offered the more secure and reliable solution for this problem. So this is a couple of requirements that this kind of tool should have. And this came from a discussion with a really big international NGO that covers public transparency and anti-corruption. That is called Transparency International. I kept a couple of discussions with them, and they are really, really curious about the opportunities to use blockchain and Web3 and zero knowledge to solve this and tackle this issue. So for this kind of tool, you need an identity management, and this is a tricky part because you need to provide wallets, for example, to all these employees, and especially you should have the possibility to recover the private keys of these wallets. And these wallets, you need to prove that you had the legal stance to make a complaint, that you need to prove that you are part of this company without revealing your identity, right? And the identity management, should have 3 levels or 3 different kinds. One is public identity. You may have, you could have like present a complaint with your legal name if you want. But if you want to keep your identity private, you should have 2 options. One is anonymity. Just generate a complaint without any trace of the identity of the person, but again, proving that you got the legal stance, or using pseudonymity. And pseudonymity is like a nickname. Usually that's the case when someone have more information about the law has been broken, or the complaint that they made. They present some information, but they want to keep track on that, and they want to keep providing more information or more details or more proof of this issue. So they could use a nickname to trace that this is the whistleblower, that you can identify the whistleblower without knowing who this person is, right? The other requirement is that all these complaints should be public. So that's an easy part for us, or for this industry. And the chance to make a tracking, a follow-up of these complaints. So the possibility to create a dashboard that you can trace these complaints and everything. But also the tool should have the possibility to change your identity type. If you start a complaint as under anonymity, you should have the chance to change that, to move that to a pseudonymity, or even revealing your identity, right? But never in the other way, but just that side. So we have the chance to deliver this kind of tool in a really better shape that the current industry that you can see around. So what are the challenges? Providing secret ID wallets to employees. And again, like you need to break this. You need to break this resistance to new technology. And of course, like, let me jump that the chain abstraction is a great, provides several opportunities to solve this issue, that the users and the companies could feel these tools like a Web2 app without knowing that there is a wallet, that you need to sign this transaction and everything. So you can build this in a really frictionless way. Of course, the opportunity to wallet recovery or private key recovery for employees, because imagine that someone start working in a big company and they receive this wallet for whistleblower, and 5 years ahead, they get something that they want. They want to introduce a complaint, and they completely forgot these keys. So they should have a chance to recover these private keys, again, without revealing who they are. And of course, this should be built in a non-custodial way, right? Of course, that create a really useful and easy to track dashboard for all these complaints. And in the case that someone wants to build this, need to remember that every single country in the European Union made a law to rule on this issue. So the tool should be customizable. That you need to be able to tweak this tool for every single country, because the laws among these countries are more or less the same, but there are some differences. So you need to be able to cover this. And the bottom line here is that, again, like CK is the brings the solution for this issue. And again, this is an opportunity to onboard other industries on Web3. And this is something that I want to point out, because when you try to integrate blockchain on the public sector, there are several blockers in this. And mostly it's about that they don't know the technology. They don't understand the technology. They only know, crypto, Lambos, that kind of stuff. So the importance of this opportunity and the whistleblower stuff is that the directives and the laws requires the people to, so these companies and these public entities like the City Hall or something, they need to provide their own service or tool or hire a tool for that. So it's not that like you need to convince the government to create something nationwide, but you can create a company, create this tool, provide that service, and prove that your tool is way better than the other opportunity, the other companies that offer these whistleblowing tools. So that's a really good opportunity to leverage compliance for mass adoption of Web3, of blockchain. And again, chain abstraction makes that path frictionless. So this was the presentation that we prepared for ETHDAM Hackathon, and also it's an invitation for anyone who wants to, try to fix this issue. There is a big market out there. And if you have any question, I'm in the CK Telegram group. We can dive deep on this, and even we can connect some people, some big organizations that are trying to follow on this issue.
You seem really passionate about this. Is Boris being like really harsh to you at DevHub, and you want to whistleblow about Boris?
Not now. I can confirm or deny that. So I need a tool to express myself. No. This is actually, I discussed this with several people in the ETC hackathon last year at Paris, and I keep discussing this with the Transparency International team. So we guess that this is a really big opportunity for the integration of blockchain on the other industries, and provide real solutions with the technology, right?
Awesome. Does anyone have any thoughts around this? Want to build it, hire Jose as their marketer? Yeah, I think a lot of people are hopping off the call. They've got places to be, but I'm happy to hang around for a few more minutes, and I'm sure Jose is. And I know Manza also wanted to. Yeah, I think most people are going. But yeah, Manza, do you want to explain anything about, sorry, remind me of it, social something, and just give a quick bit about how people can learn more, and then maybe next call can go into
Absolutely.
it more.
Yeah, hey guys, we can discuss about TosaCap later on the next community call. But basically, we have been working on last year now on the channel, verifying the authenticity and of credential on the basically it's a community-based attestation protocol, right? And we enable an easy self-validation and issuance of credential. We have basically have used validator that are real people that validate all the evidence that the applicant provide for the credential. And well, basically we are working on what we call the social consensus layer. Is something that we are looking for when it's could be a match on the other layer. But basically, I'm really excited to see all the work that all the people working, and also excited to see the Octopus layer that students are working on. Just one moment. We have been working. We have supporting Mina Foundation on Mina Navigator program that basically is something that for the Mina dev community, basically to provide all the credential system for the badges that the developer obtain for working on the project. And the next step for us is to provide a chain agnostic credential system that obviously is going to be made on NEAR. So really excited to see what Octopus is working, and also to have a chance to collaborate with that pretty much.
Awesome. Yeah, I think a lot of people had to drop off, including Octopus. So
Yes.
please put more information in the chat,
Okay.
and I'll be happy to ping any specific people. But I think you said you knew the Octopus guys before, right?
Mm-hmm.
Yeah, I think. But yeah, we should definitely have you talk more about this on the next call. That'd be great.
Absolutely. Thank you.
Okay. Any last things people want to shout about, or let's end it here, I think. Okay, yeah. Thanks for sticking around till the end. See you next time.
Hey guys.
Thank you.
Thank you. Bye-bye.
Thank you. Bye.